friends, welcome again in my channel Learn with Anu. I am back with another interesting and logical video on ideal gas law with experiment. So let's begin with the synopsis of this video. The synopsis of this video. First we will learn the concept of ideal gas equation, its experiment, and finally the conclusion of this video. Ideal gas law describes the relationships between measurable properties of an ideal gas. The law states that PV equals to nRT, where P is pressure, V is volume, N is the number of moles of molecules, T is absolute temperature, and R is a gas constant, that is 8.314 joules per degree Kelvin or 1.985 calories per degree Celsius. A consequence of this law is that under constant pressure and temperature conditions, the volume of gas depends solely on the number of moles of its molecules, not on the type of gas, also called universal gas law. Egg in a bottle science experiment supplies egg, matches, milk bottle, paper. Now the method. Cut a strip of paper 6 to 8 inches long and 3/4 inches wide. The paper should be narrow enough to easily fit in the bottle and long enough that it ends below the top of the bottle. When placed fully inside, get our eggs ready, peel and nearby. Light the piece of paper and drop it into the bottle. Flaming paper inserting into bottle. Quickly place the hard-boiled egg on the top of the mouth of the bottle. Place egg on the mouth of bottle. Now understand how did the egg get sucked into the bottle. This is a classical science experiment that demonstrates the power of pressure. It looks like the egg is getting sucked into the bottle. It is just high pressure winning over low pressure, and air pressure follows something called the ideal gas law. PV equal to nRT. Pressure multiplied by volume equal to number of moles multiplied by gas constant R multiplied by temperature. This is a cool way of remembering that when temperature goes up, pressure goes up too in a fixed environment like a milk bottle. So what is happening in the experiment? When we start, the air pressure inside the bottle and the air pressure outside the bottle is equal and the egg cannot move. But as the paper burns inside the bottle, the temperature goes up, causing the pressure to go up. After we place the egg on the bottle top, it seals up the bottle a bit but still allows the high pressure to force the air out of the bottle. This is why we may get to see the egg do a little jiggle on the top. But when all the air is forced out of the bottle, the burning paper runs out of oxygen and cannot burn anymore. So the flame goes out, and as we can guess, when the flame goes out, the bottle cooled and the air temperature goes down, and so does the pressure suddenly. The pressure on the outside of the bottle is higher than the pressure on the inside of the bottle, and pop. In goes the egg because of high pressure won over low pressure, and air pushed the egg in the bottle. Watch it pop inside the bottle. Now the egg inside the bottle. Let's watch the experiment in action in this video. Safety first. This egg in a bottle trick is best done as a demonstration by adults. Children should never use matches or a lighter. Have the adult complete the part of this experiment that deals with lighting the matches and burning the paper. Always keep matches and lighters out of the reach of children. Also keep a fire extinguisher nearby in case of emergency. The classic egg in a bottle experiment. an egg, some fire, and we have not a really cool bottle trick on our hands and some fascinated kids ready to learn. Try this classic egg in a bottle experiment for a science trick that will wow the kids. Plus, it makes learning fun for in class, at home, or in scouts and clubs. Conclusion of this video. We know the ideal gas equation PV equal to nRT. As temperature increases, pressure is also increases. So, because high pressure 1 over low pressure, so the air pushed the egg in the bottle. Hello friend, this is all about the ideal gas equation and its experiment. For any query and suggestion, please comment in the comment section. Like, share and subscribe this video. Thank you.